Okay, welcome back. Happy Thursday, everybody up here. Everybody up here. All right, so one thing, I've decided to record this class. I'm just going to record the class the first time I do it, and sometimes that'll be you guys, and sometimes that'll be my other class, and that way nobody has to wait for a video to get posted. So today we're going to start with lesson 4. We'll do all of that, and then we'll come back and start 5. So lesson number 4 is about dimensional analysis and ratios and proportions. It's kind of a long demo, so apologies up front. We're going to try to skim through it as quickly as we can so you can jump into the activity, but there's a lot going on in this lesson. So I think that's that. Just a quick heads up, 1 week from today, September 17th, is our very first quest. Quest is bigger than a quiz, not as big as a test, so just kind of merge those words together to get quest. The quest is on, you can see here, it's not quite showing on the screen. Nope. The quest is on lessons 1 through 5. So everything 1 through 5. Today we're covering 4 and starting 5. And that's what the quest will be on. We'll talk a little bit more about that on Tuesday, but it's a week from today. Okay? I don't know. It's either like 2 or 3 pieces of paper worth, but I don't know how many questions there are. The intent is that it will take you less than an hour or 10 minutes. It might take some of you half an hour. Good. Okay. So again, we're starting on page 26. Just a couple of quick announcements. First of all, one more handout that I've given you. I promise this will be the last handout for a long time. Grab one of these guys that says My Math Lab Tips and Tricks. Everybody have one? They're on the table. So last class I gave you guys a handout that was hopefully going to save you some frustration so you can avoid some of the common pitfalls that students run into when they use My Math Lab. Now that we got the frustration piece out of the way, this document will help you become an expert and save some time when using My Math Lab. All right? So read through that. Will help you do things a little bit more efficiently, quickly as you're working through My Math Lab. Okay, and then last thing, the syllabus assignment that most of you have done by now, one of the questions is what questions do you have for me? And some of you had questions for me, which I want to respond to here in front of you all. So somebody wanted to know what's the easiest or most common way to fall behind in the math class? And I'll tell you that it's to just not do anything outside of class. And that catches up to you very quickly. Some people just think, okay, I can get away with just coming to class and doing my work in class and that's enough. And that is very rarely enough. I don't think it puts most people in a good position to succeed. The rule of thumb is typically about 3 to 4 hours outside of class for every hour inside of class. And we meet for an hour 40 minutes. So we're talking like 5 hours or so for every class that we have. You're working like 5 hours between classes. It's a commitment. It's a 4-credit class. It's a lot. So that's the easiest way to fall behind, is to just only come to class and don't do anything else. Missing class is another really easy way to fall behind. You don't want to do that either. Thank you for the question. And then somebody else wanted to know if I dropped the lowest quiz or test. The answer is no. I'm sorry, but I don't. I'll pull up so we can look at all the quizzes and tests. We have we have 5 different quests throughout the semester. You can see first quest we already mentioned, then we have another quest coming up there. We have our first test here, quest 3, quest 4, second test, quest 5, and then a final exam. So 5 quests, 2 tests, and a final exam. That's 8 things altogether. I feel like if I drop 1 out of 8 things, that's a large percentage of things to drop. It's 12.5%. So I don't do that. What I do is give you guys a lot of resources to help you prepare and put your best foot forward on the 8 assessments that we have. And one of those resources is that big packet of practice problems that we talked about a little bit the other day, and we'll talk about it again coming up on Tuesday. Okay, thank you for that question. All right, on page 26, jumping up here to the top. In this lesson, we learn how to use dimensional analysis to do unit conversions and to help us set up proportions to solve application problems. Just a reminder, I think we saw this last class. If you answer a homework problem in My Math Lab and it says you're wrong and you look at the answer and it looks the same as your answer, just send me a quick email. I can take a look at it. Don't go crazy trying to figure out what the difference is between these two things that you think look exactly the same. Okay, number 1. Brandine, could you read 1?
Gas costs $3.
All right, let's pause right there. So $3.57 a gallon for 12 gallons, and then another $15.35 for other stuff. Taking a look at number 2, do you buy this is the right calculation to do? $3.57 times the 12 gallons that we bought, and then we add the $15.35, and you can check the calculation later if you want. So $58.19 is the total bill. Reasonable? What I want us to do is write in some units here. So jumping down to number 3 with all these blanks. It's the same calculation, 357 times 12 plus 1535 equals 5819. But I'm going to put the units in the blank words here. We'll start with the 12. That's 12 what? That's 12 gallons. 1535. That was dollars. Let's just write the word dollars there. And the 5819 dollars. And then the trickiest one is that 3.57. It's dollars per gallon. Yeah? Every gallon you buy costs you $3.57. So dollars, and then per in math means divide, right? So dollars per gallon. Now, any equation that has units in it, all those words we just wrote are units. The units on the left side of the equation have to match perfectly the units on the right when all is said and done, yes? It wouldn't make sense, like you guys all believe that 5 times 2 is equal to 10, right? Fine. But if I said 5 times 2 apples equals 10 oranges, is it still true? No. So we got it's not enough just to have the numbers be equal. We need the units to match up. Okay. So let's make sure that the units match up. So taking a look at the left-hand side, I've got a dollars per gallon times gallons. What happens with those gallons? They cancel, right? You've got gallons on top of a fraction, you've got gallons on the bottom of a fraction, and they just disappear. So all that's left when I do that multiplication is dollars. It's the dollar amount of the gas by itself. And then you add the dollar amount of the other stuff, the $15 worth of stuff, and you end up with a total dollar amount. There's nothing earth-shattering here, gang. It's just paying attention to the units and recognizing that, that the units on the left have to match the units on the right. Okay, moving on to number 5, changing gears to talk about ratios and then ultimately setting up some proportions. Let's just jump down to this original equation in number 7. So that right there, fancy math word for that equation, anybody know it? It's one of the bold words in the previous sentence. That's a proportion. Proportion in math is just a fraction equaling a fraction. Now there are 2 main techniques for solving a proportion. Raise your hand if you've heard of cross multiply. Looks like everybody, maybe almost everybody. Super. If you want to cross multiply and you're good at it, by all means, go ahead and cross multiply. But I'm going to try to avoid using that phrase because I think it's quite risky. Suppose that I give you this separate example from that. 2 over 7 equals x over 5 versus 2 over 7 times x over 5. So cross multiplying here says what? 2 times 5 equals what? 7 times x, right? The product of the diagonals. What's the answer to this multiplication problem here? When we multiply fractions, it's 2x over 35, right? But if you just memorize this cross multiply, which by all rights is a magical thing for most people that do it, no idea why it works. Some math teacher said, multiply the diagonals and they're equal. Magic. But it's really easy, if that's magical to you, to bring that same magic into this multiplication problem, and somehow, and I see this all the time, 2 times 5 is 10, 7 times x is 7x. I see this as the answer to that multiplication problem, and that's not the right answer. Because we know for multiplying fractions, you're supposed to go straight across. So the only reason I'm not going to use the phrase cross multiply after today is that sometimes this magic diagonal thing gets in the way of you already knowing how to multiply fractions, because frankly, these purple things look an awful lot alike, but the techniques are different. So in lieu of cross multiplying, check this out. What we're going to do is take this yellow fraction, and we're going to multiply both sides by both denominators. I say again, we're going to multiply both sides by both denominators. I see a 7 and I see a 5. So on the left-hand side, I'm going to multiply by a 7 and a 5. And on the right-hand side, I'm going to multiply by a 7 and a 5. And that's a perfectly legal thing to do, yes? As long as you do the same thing on both sides. It's not clear why I want to do that, but it's legal at the very least. And the nice thing is that if you multiply both sides by both denominators, then lots of stuff cancels. On the left-hand side, I see a 7 in the bottom and a 7 in the top, and they cancel. That's why I put the 7 up there. What happens on the right-hand side? The 5s cancel. And so what we're left with is 5 times x minus 1, and there's no fraction. And on the right-hand side, 7 times 3, which I will circle down here. 5 times x minus 1 equals 7 times 3. Yeah? Now go back to the yellow thing. If we had tried our magical cross multiply, what would we have said as our next equation? 5 times x minus 1 equals 7 times 3, which is exactly what I have. That's exactly what cross multiplying is. So it's not magic, it's really just this reasonable idea of multiplying both sides by both denominators. Admittedly, okay, it saves you 2 lines if you just cross multiply. But if cross multiplying is going to confuse you when it comes to multiplying fractions straight across, don't do it. Do this. Multiply both sides by both denominators. Okay, solving that equation is pretty straightforward at this point in our class, so we're not going to look anymore at that one. Just our note, if you cross multiply, make sure that you know exactly what you're doing, because otherwise it is risky. Okay, totally fine with me, but just know the risk. Amy. It's getting to the same answer as cross multiplying, but making it so it's not magic and it's not memorized this whole.
No matter what you do.
Yes. Cross multiplying is a perfectly fine technique, but I just want to make sure people don't use it when it comes to multiplying 2 fractions, and they only use it when it comes to equating 2 fractions. Okay. All right, next page. So here's our first word problem for the day. It says the ratio of female students to male students at GCC is 3 to 2, and that's actually pretty close to the real number. 3 to 2 ratio, slightly more females than males. It says there are 2,000 students at GCC, and then we're going to answer the natural question. How many guys are here and how many girls are here? So first thing we'll do is define a variable. I'm going to let x equal the number of female students. Just as well could have let it equal the number of male students. Notice I've got these things circled. I've got a quantity word and I've got a unit word. Very common for me to see stuff like this. Let x equal females. Also common when I see stuff like this is for me to cross it off and say something like -2 points on a test or a quiz, because letting x equal females is not a reasonable definition. First of all, every x that we introduce in our problems has to be numerical in nature, and females are not numerical in nature. But that's not enough just to give me a numerical thing. When we say x equal females, are we talking about the height of the females at GCC? No. Are we talking about the hair color? No. We're talking about something very specific. It's how many, right? So just make sure that you are clear. It's not just some generic x equals females. It's a number of females. If this problem had to do with height, you'd say height in feet or height in inches or height in miles, but it's got to have a unit attached to it, and it's got to have a quantity word. Okay, so we are going to walk through this process here for setting up this problem. So first, blank fraction equals blank fraction. And then down here in the next line, I'll highlight it here. What's going to end up happening is I'm going to put some number stuff here, put some number stuff here, don't fill those in. And then in this other fraction, I've put females in the numerator and males in the denominator. That's an arbitrary choice that I made. Perfectly welcome to flip it over, but the key is that you start getting some of these unit words written down. Females and males are important in this problem, so we get the units written in there. And now we're going to start filling in with the givens in the problem. oh, sorry, what we're actually going to do is copy that same order over here. You guys buy, if we're saying females are in the numerator on the left, then something representing females had better be in the numerator on the right. We've got to make sure that the pieces are in the same spots. So females there, males there. Okay, so let's get this ratio business. It said the ratio of females to males is 3 to 2. Females to males, 3 to 2. So in that left-hand fraction, the blank one, put the numbers 2 and 3 in the right order. Females to males, 3 to 2. Which one goes on top? 3 there, 2 there. Yeah? If we had chosen males above and females below, what would happen with those numbers? Just swap them, no problem. Okay, next thing we're going to do is bring our x into the problem. Look up above, I typed it. What does x represent? Number of females. Yet another reason to be clear about your variable. You might have forgotten which one it was at this point if you hadn't written it down, had it in front of you. So I guess that means we're putting x where? The females, which we decided was up in the numerator. Just picking the same thing, same relative locations. Okay, there's only one other piece of info in the problem we haven't used. What is it? 2,000. We have not used that. That's important. Really tempting to say, okay, well, I've got one piece of info I haven't used. I've got one blank. Lennon, why can't we put it there? We can't put 2,000 there. 2,000 is a total number of students, but what's supposed to go down there is a number of males, right? And we can see that there's a mismatch because we took our time and wrote the word males and wrote the word female. This thing at the bottom is supposed to represent number of males. It isn't 2,000. 2,000 is a total. So we're going to put something, it's going to have x in it, it's going to have the 2,000 in it. If you feel pretty confident that you know what expression is supposed to go there with x and 2,000, go ahead and write it. It's totally okay if you don't feel confident. We're going to explain how to figure this out if you don't have it. If you're not sure what goes down there, you just pick your favorite number for x. For example, I think I've got an example written out here. Here we go. Suppose x is 500. 500 what? What did x represent? Females. So we're saying 500 females, right? So if 500 were the number of females, then what number would we put in this blank for the number of males? 1,500. It's not so important what that number is. The important thing is how we get it. How did we get from this 500 here to the 1,500 up there? Subtract 2,000 minus the 500, yeah? I think it's written there. 2,000 minus 500, that's the calculation. But then we'll just go back and say, okay, but it wasn't 500, it was more general. It was x, right? So 2,000 minus x is the thing that goes right up here. So some of you might have known that without doing this make up a number idea, but no problem if you need to make up a number. It's one of the techniques from our last class, and I still think it's a very powerful one. If you're not sure what to do with x, just make up a number. Usually things fall out. Okay, so down here is the proportion that we just ended up with. Getting to that proportion is like half of the problem, and then solving it would be the other half. That's going to be the first thing you do in the activities, but there's one more thing I want to demo, so you're going to pause on that guy. And we're going to move on to the next page and try this problem about babies. And then you'll solve that proportion in just a few minutes. Okay, so here's a fact. In the US, a baby is born every 3.2 seconds. Now, just because I typed this in the packet doesn't mean it's true. Some of these numbers I just completely made up. So if you try to verify these and it's not anywhere near reality, it's because I just made it up. So, baby is born every 3.2 seconds. Here's the question. Is how many babies are born in the US each decade? That's the question. If it's one baby every 3.2 seconds, I want to know how many every decade. So we're going to fill in this big blank space together. And here's what we're going to do. We're going to multiply right here to try to get closer. We're trying to get from seconds to something closer to decades, which is pretty far. There's a lot of converting we're going to do. But what's the next larger unit of time after seconds? Minutes. Okay, so I'm going to put something over here. Now don't copy this just yet because we got to figure out which one we're supposed to put. But we're going to put minutes and seconds. So you guys all buy that 1 minute is equal to 60 seconds, yeah? So that means that if I put, for example, 1 minute here and 60 seconds here, don't copy that, but if I put that, what is the value of that purple fraction when all is said and done? No, not the babies, just the purple. 1 minute divided by 60 seconds. What's the value of that fraction? It's 1, because 1 minute is exactly the same as 60 seconds, yes? If you have a fraction 17 over 17, what is it? It's 1, because they're exactly the same on top and bottom. So 1 minute and 60 seconds are two different ways to say exactly the same thing. And if I multiply 1 over 3.2 times the number 1, that's legal. It doesn't change anything, yeah? If you just multiplied 1 over 3.2 by 84, you've changed it. I'm not allowed to change it. I'm just going to convert it into something that's the same. So if you decide to put 1 minute over 60 seconds, can you cancel any of the units? I see seconds and I see seconds. Can I cancel them? No. In order to cancel them, I need one to be up and one to be down. And right now they're both down. Yeah? So this is not the right fraction. What's the right fraction? It's 60 seconds over a minute, which is still a legal thing to multiply by. So this is something you should copy. 60 seconds is the same as 1 minute, which means that purple fraction is equal to 1, which is the only reason I can multiply by it. And then we're going to go ahead and cancel some units here. So seconds cancels. We'll go to the calculator at the very end, but at the very least, we're getting closer. We were at seconds, now we're at minutes. We're trying to get to decades. We're heading in the right direction, yeah? Let's multiply by the next thing. Next unit of time after minutes is hours. So your job is going to be to put hours and minutes in some order in this next fraction. Make your choice. You need the units to cancel. Do you want hours on top or do you want minutes on top? Do you want hours on the bottom or do you want minutes on the bottom? There's only one right way to put this. What should we be putting on top? Hours or minutes? Minutes there so that it will cancel with the minutes that we already have, which I guess means we got to put hours downstairs. I like to put the units first and then fill in with the numbers. What goes in front of minutes? 60 in front of hours. 1. Super. And then cancel. Minutes and minutes. Okay. I believe that there are 3 more fractions that we're going to need to put in here. Currently we're at hours. We need to get to decades. Yeah, 3 fractions. So your first task, not really officially part of the activity, but I'll just stop talking now, is to fill in 3 more fractions. And once you've got all the units to cancel and you have decades at the very end, only at that point you're typing into the calculator the whole thing. Nick? Great question. There are some leap years involved in a 10-year period, right? Yes, right. Yeah, let's ignore the leap years, but it's a fantastic thing to think about. Okay, so you're filling in 3 fractions. Hopefully stuff cancels. If you get stuck, ask your neighbors. If your neighbors are all stuck, raise the flag, and then move on to the activity.